Good day, I'm Dr. T and welcome to my dining room table. So today I would like to talk about oxidation reduction reactions concerning alcohols. Yeah, this is a really big topic for organic chemistry with redox reactions, but I'm only really going to focus on alcohols because they give you some interesting characteristics of organic redox reactions. And they're inherently quite valuable, or at least an understanding of them is going to be applied into biochemistry moving forward. Okay, so for this one, I'm going to look at really kind of three different types of alcohols, primary, secondary, and tertiary. So primary alcohol, just to call that to your remembrance, is going to be this guy. So he's a primary alcohol. He is an alcohol where the carbon that the OH is attached to one carbon and two hydrogens. Okay, now for an oxidizing agent, the generic term, or the generic symbol for that is going to be an O in brackets. So this could be quite a few different things. Potassium permanganate is classic, a couple of different choices. In this case, I'm not really focusing on what it is. There are definitely characteristics of different oxidizing agents and their ability to actually do these reactions. Okay, so the primary alcohol, if I put one equivalence, that means I put enough oxidizing agent to react with however much primary alcohol I have. Then I'm going to oxidize this, and the way I do that, I'm actually going to be pulling off water in the process. So I'm going to have my carbon, and when organic molecules get oxidized, and you probably will have seen this in a biology class, you will get more bonds to oxygen typically and less bonds to hydrogen. And we definitely see this with primary alcohols where you get an aldehyde in the process. Now, if you add another equivalence, so enough to react with it again, of oxidizing agent, we can continue along the reaction. Basically, these hydrogens are being pulled off typically. So now we can take this aldehyde and we can turn this into an acid. So we remove the hydrogen and put an OH there. So we've got another bond to oxygen, one less bond to hydrogen. Essentially, we are pulling off pairs of electrons each time. Yeah, so you're putting the oxygen on, that's hogging the electron, you're taking the hydrogen off, and it's sharing it with some other, probably an oxygen, but not necessarily. There are oxidizing agents that have no oxygen involved at all. They just have to pull off electrons. Okay, so this is the fate of a primary alcohol. And actually, we could look at a primary alcohol like ethanol, which simply would be this. And this is what takes place in your liver. Now, there's going to be some enzymes involved, so it's a little bit more complicated than just simply oxidizing agent. But if you have, say, ethanol, if you consume that, that's the traditional drinking alcohol. It's the one that is least deadly to you, although in large enough quantities, anything will kill you, and people have definitely died from alcohol poisoning. Anyways, so with this one, your liver is going to go through a two-stage step. One will form an aldehyde. Now, if you recall, aldehydes are typically fairly toxic. These are great electrophiles because of the carbonyl here, and then the hydrogen doesn't provide much steric hindrance, and therefore any stray nucleophile is going to bond to it, and you create a mess. Not to mention, you can continue this reaction over it, and this can become a reducing agent, and then forming the acid, but with something that was not supposed to be an oxidizing agent. So you can have a lot of really messed up reactions when it comes to aldehydes. They're not something you want to have. So your body actually makes a very good point of going from here to here very quickly, so that this doesn't stay present for any length of time. Now, this is acetic acid. This will then eventually get turned into energy. Eventually gets turned in your liver to CO2 and water. However, before it does that, these guys can cause some damage. Actually, all three, but these guys are the ones that cause most damage. Specifically this guy. This is why if you consume lots of ethanol over a long period of time, this can cause damage to the tissues that are trying to process it, aka the liver, and as we know, alcoholics get cirrhosis of the liver, which is, bad. So I would encourage you, don't drink enough that it damages your liver. Also, don't drink and drive, because what usually kills people is it impairs their judgment and then they, drive a car into something. So be responsible with your ethanol. Now, a couple interesting quirks. In Russia, there is a technique or a treatment for alcoholism that will never, ever, ever get US FDA approval. And that is, there is a chemical that was discovered. It was actually discovered in the rubber manufacturing industry that blocks this part for alcohol metabolism in the liver, builds up the aldehyde. You feel like you're going to die. And so basically, you get an injection of this chemical. The doctor tells you, it gives you a shot of vodka. You feel like you're going to die. And he's like, if you ever drink again, you will die. Even though the chemical leaves your system within hours, is all placebo. Yeah, that ain't going to get FDA approval, although apparently it does work for some people. Now, that is with primary alcohols. Let's go to secondary alcohols. So secondary alcohol, by definition, the alcohol is on a carbon. It's got 2 of its 4 bonds, 1 of which is the alcohol, 2 are the carbons, and 1 is still hydrogen. So in this case, we can put 1 equivalence of oxidizing agent. It's going to pull off a water. It's going to pull off a pair of hydrogens, I should say. Typically, this is going to come off in the water because you probably had an oxygen going on over here. And you're going to get yourself a ketone. And you can't go further because you don't have a hydrogen to pull off. So typically, you're going to pull off a hydrogen, that guy, but you don't have him to pull off. Let's look at the last one, which is a tertiary alcohol. And tertiary alcohols, by definition, the carbon is attached to 3 other carbons. And so in that case, you'll notice all of the hydrogens you can pull off that are attached to the carbon. Yep, no reaction. And yeah, we've got ourselves our oxidation. So this is a fairly common pathway. We're going to revisit this once we talk about enzymes and how they function towards the end of this video series. But it is definitely an interesting scenario. This is also a way we can identify primary versus secondary. For tertiary, we put an oxidizing agent, see if it reacts. Kind of an old school approach to do so. So with that said, have a wonderful day, and I'll see you later videos.